Yeah. Everybody see here in the problem number 9 that you're seeing, for the circuit given, you have two parallel branches here, okay, with resistor and inductor in series and with 4 ohms and the capacitor of zero point 0.4 farads are in series, and a 12 volts is being applied to the switch. What is the switch symbol telling you? The switch symbol is telling you that the switch is being opened at t equal to 0. Okay, the symbol very clearly shows that the switch is being opened at t equal to 0. Understand? So when this is the condition, they are asking us to find out the I of 0 plus and V of 0 plus. Okay, what is I? I is the current that is flowing through the inductor. Okay, V is the voltage that is dropping across the capacitor. Always in transient analysis, will we look at the current through the inductor and voltage across the capacitor. Fine. So they have asked us to find out I and V at t equal to 0 plus, and also they have asked us to find out the first order differentials of I and V with respect to t. Okay, and for a change they also have asked us what is I of infinity and V of infinity. We'll be talking about this. Okay, now they have not talked about the condition wherein this particular circuit would be in steady state. They have not talked about. Okay, if they have not talked about the steady state condition, we have to assume it. What way we can assume? They are telling that the switch is being opened at t equal to 0, right? So that means the switch was closed for t less than 0 for a long time. That means when the switch was closed for a long time for t less than 0, the circuit was at steady state at t equal to 0 minus or t less than 0. Understand that? So steady state conditions needs to be understood. So that is how we can find out I of 0 plus and V of 0 plus. How can we find out I of infinity and V of infinity? How can we find out that? We can find out I of infinity by V of infinity. That means we are going towards positive. That means t equal to 0 means after a long duration, we assume that t is infinity. Infinity means it's nothing very big. It's after a long time is what you need to understand, after a long duration. So after the switch is open for a long time, okay, the circuit would again be in steady state. That means whether the switch is closed for a long time or open for a long time, okay, the circuit would anyways be in steady state. So we have to consider the steady state conditions twice here. Once with the switch open, okay, once with the switch closed. Understand that? So with switch closed, when was the switch closed? Switch was closed for t less than 0. So that means for t less than 0, the switch was closed for a long time and the circuit was in steady state, is what is the assumption that we need to make. Okay, so shall we go about it? Everybody in the solution, just say that. What is that we have to understand? The switch, everybody just copy it down. I hope everybody is preparing the notes for this. If not, you'll not be learning anything. You have to work out and learn. Okay, the switch is opened at t equal to 0 is the first point. What is the second point? What is the second point? Okay, the second point is this switch was closed for a long time. The switch was closed for a long time, okay, at t less than 0. So this implies that the circuit was in steady state. Circuit was in steady state at t equal to 0 minus. So when the circuit was in steady state, it also implies what? it also implies that L is short circuit and C is open circuit. So everybody write the circuit diagram at t equal to 0 minus. Therefore, at t equal to 0 minus, how the circuit would look like? Everybody write it. You have to replace L by short circuit and C by open circuit. Everybody do that. So this is the voltage being applied, 12 volts. Fine. Then you have the resistor. Here is the inductor which you are short circuiting. This is short circuited inductor. Okay. And this is closed switch. Switch was closed. Then you have another resistor and the capacitor is opened. So this is open circuited capacitor. So here what you will have V of 0 minus, and what's flowing here? It is I of 0 minus. What are these resistors? These resistors 6 ohms and 4 ohms. So this is how the circuit looks like in steady state at t equal to 0 minus with switch closed. Is that understood, everybody? Now, can you apply KVL or KCL? You do whatever, okay? But get me those two parameters, I of 0 minus and V of 0 minus. How getting I of 0 minus and V of 0 minus are helpful? Because if you find out I of 0 minus, that is what is our I of 0 plus. If you find out V of 0 minus, that is what is our V of 0 plus. Understand that? Okay. So let's go with it. Now there are two paths for applying KVL. Everybody just observe here. There are two paths. Okay. See here. One path is this. One path is this. Okay. Another path is this. In this path there is no current, but we need to somehow find the path where V of 0 minus is lying. So this is the path where V of 0 minus is lying. You can go even with this path to find out V of 0 minus. Okay, but understand, this is the path to find out V of 0 minus, and this is the path to find out V of 0 minus. There are two paths to find out V of 0 minus, whereas there is just one path to find out I of 0 minus. Get that point? Okay, so applying KVL to mesh 1, will not call it as mesh 1. Okay, so we will say, okay, I'll make it a dotted path. This is mesh 1. Okay, let's see. Okay, this is mesh 1. Yeah, KVL to mesh 1. We are not what marking current there. Fine, we're not marking current, but that current is already flowing. Okay, and that current would flow in this path only. KVL to mesh 1. What would that give us? It's minus 12 plus 6 into I of 0 minus equal to 0. Okay, so this implies what? This implies that I of 0 minus is what? 12 by 6. Okay, and that is 2 amps. Since current through L does not change instantaneously, What we can say? Since the current does not change instantaneously, what we can say? We can say this. What is it? I of 0 plus is equal to I of 0 minus, and that is equal to 2 amps. Everybody okay with this? Now what we need to do? We need to find out V of 0 minus. Why we have to find out V of 0 minus? Because we have been asked to find out V of 0 plus also. Okay, so let's find out V of 0 minus and then say that V of 0 plus is actually equal to V of 0. So how to find out V of 0 minus? See, let's go with this outermost path. KVL to outermost path, we should say that. Okay, KVL to outermost path. You have to be little careful here, because in that path there is a resistor 4 ohms. You see this? This is 4 ohm resistor. Fine. Now, is there a current flowing through this 4 ohms is the question. We are going with this outermost path. This is the path we are going. When we are going in this path, do you think any current flows through 4 ohms? No, no current flows through 4 ohms because there is an open circuit here. Okay, so whatever the current that flows as I of 0 minus keeps flowing in this path only. Keeps flowing in this path only. No current flows in this path because there is a open circuit. But that does not mean that there will not be a drop. There will be a drop. Okay, but no current flow. Is that understood? Now, how to apply KVL there? See here, everybody, it's minus 12. We are moving in clockwise direction and we approach the minus sign first. Then we get 4 ohms. So it's 4 into 0 because no current is flowing. Then we have not written the polarities. It's plus, minus. Okay, so it's been given in the problem itself. We have not taken that, or we have not written that. Yeah, see, it's given plus, minus. Okay, so plus, minus, if you take, we are approaching the positive polarity of positive sign of the voltage drop there. So it's plus V of 0 minus. Okay, algebraic sum of all this should give you 0, which implies that V of 0 minus is 12 volts. Okay, again you'll make the same statement. What is that? Since voltage across C does not change instantaneously, okay, what we say, V of 0 plus would be equal to V of 0 minus, and that's equal to 12 volts. Everybody get this point now? So what we have found out? So we have found out this. I of 0 plus is found out now. Okay, and V of 0 plus is found out. We have to find out the first order differentials. So how to find out the first order differentials? Okay, to find out the first order differentials, we need to consider this circuit at t equal to 0 plus. Okay, so how would that look like at t equal to 0 plus? Fine. So whatever we have done here is to find out what? Is to find out whatever we have done till now is to find out A of this is question number A. In question number B, we have to find out the first order differentials. That is to find di of 0 plus by dt, okay, and dv of 0 plus by dt. So what we do for this, we consider the circuit at t equal to 0 plus. What has happened to the switch? The switch is opened at t equal to 0 plus. What's happening? See here, everybody. At t equal to 0, the switch is being opened. That means at t equal to 0 plus, the switch would be open, just open. Okay, so it is just open now. Let's write that. Everybody just copy down the circuit. I just copied and pasted it. Yeah, just change this circuit at t equal to 0 plus. What is going to happen at t equal to 0 plus? What we should do? At t equal to 0 plus, this is open, mind you. Okay, and what's flowing? What is flowing? I of 0 plus is flowing here, and V of 0 plus is dropping here. So this is the circuit diagram at t equal to 0 plus. What is happening at t equal to 0 plus? Switch is open. You should understand. With switch open, I of 0 plus is flowing here and V of 0 plus is dropping across this. So can you find out I of 0 plus and V of 0 plus now? Sorry, that has been found out. You have to just apply the KVL and try find the first order differentials and second order differentials. See, here we cannot do that because there is no current flowing in this path. In this path, yes, there is a current flowing. After it comes here, it goes here, right? So we need to be a little careful. Let's go with clockwise direction only, okay, and see what happens. Okay, so this part we are not bothered about now. This part is of no use to me. Okay, so we'll be dealing with only this particular part. Fine. So KVL implies what? KVL helps us to get the first order differential of current. Okay, so applying KVL. Mind you, we are moving in clockwise direction only. Okay, so here, what is the voltage across the inductor? What is voltage across the inductor? What is it? Anybody? It's L into di of 0 plus by dt. Okay, we are moving in this direction. Okay, and what's happening? Since we are moving in this direction, the current is moving opposite. Okay, so we need to have a negative sign to it. Also, there is 6 I of 0 plus. We are moving in clockwise direction, and I of 0 plus is moving opposite to our direction. Okay, then comes 4. It's minus 4 into I of 0 plus, because when I'm moving like this, okay, so I of 0 plus is going like this. Everybody understand that? So it's again minus 4 I of 0 plus. Then comes this. It's minus what? 1 by C integral, okay, I of 0 plus dt equal to 0. Every term is having a negative sign because I'm moving in this direction. Okay, the current is moving in opposite direction. Okay, so every term should have a negative sign. Fine. Since every term has got a negative sign, you can multiply the whole equation by -1 and you can make all the terms to have the positive signs. That can be made. Okay, so how would that look like? So this further implies that what is L? L is what? 2 Henries. 2 into di of 0 plus by dt. Okay, then plus I'm taking all plus. Okay, now 6 into 2 because I of 0 plus is found out to be 2 amps in the previous step, minus 4 into, sorry, again plus. Okay, so plus 1 by, so what is this? This whole stuff is what? This is V of 0 plus. Okay, so this is what you're going to get. What is V of 0 plus? Let me write that. So this is 2 into I of 0 plus by dt plus 12 plus 8. What is V of 0 plus? V of 0 plus is 12 equal to 0. So what would this be? What would this be? 6 into 2 and so this 12 and this 12 they say are cancelling each other. Why is that happening? Okay, so this is supposed to be plus. Very sorry. See here, we are moving in this direction, right? Okay, we are approaching the positive sign of V. So that's why we need to have this. Okay, so I think I'm rather confused or confusing you by not doing. So if I'm multiplying, let me have the same. Let me just have the same signs everywhere as I did in the first case. Okay, so let me not confuse you with the signs. Let me play with the same signs. Okay, so this is minus, but this is plus. Okay, so minus minus plus. Okay, so this and this goes off, so what you'll be left with, therefore di of 0 plus by dt would be what? 8 by 2, that is 8 by minus 2, rather 8 by minus 2, and that would give you minus 4 amperes per second. Is this okay with you, everybody? So we have found out the first order differential of the current. How to find out the second order differential is the question. How to find out the second order differential? See here. Which equation? Yesterday also we have, in the last class also we have done. Okay, just to make the things clear, I'll go back to this particular thing. What is it telling you? It is giving you the equations for voltage across the inductor, current through the inductor, voltage across the capacitor, and current through the capacitor. Which among this would give you the differential of voltage? There is only one term which will give you differential of voltage, that is current through the capacitor. Understand that? So current through the capacitor, C dV by dt. So that is how we are going to get the current. Fine. So what is current through the inductor here? So current through the inductor, I'll just what is current through the inductor given by? Here is 0.4 farads. Okay, but here this is approaching the negative, okay, of voltage. Fine. So we have to be little careful regarding that. What is I of 0 plus given as? Okay, so to find, everybody just take down this, to find uh, dv of 0 plus by dt, what we need to do, we need to consider current through the capacitor C. What is current through the capacitor is given by I or IC is actually given by C into dV by dt. This is generalized equation. Okay. So here which current is flowing through C? I of 0 plus is flowing. But when it is flowing, it is coming across negative sign of V. Okay. So what we need to do is, therefore, we can say I of 0 plus is actually minus C into dV by dt, dV of 0 plus by dt. Negative sign, negative sign, uh, because why do we have to consider negative sign? Because I of 0 plus is approaching negative sign of V of 0 plus. This is the reference for you. Understand? So therefore dV of 0 plus by dt is given by what? Is given by minus I of 0 plus by C. What is minus I of 0 plus? It's minus 2. What is C? C is 0.4. Okay, so therefore, what is this? Therefore, dV of 0 plus divided by dt is 20, okay, minus 5 volts per second. Many of them misses on this negative sign. Okay, but that is important because negative sign is considered because I of 0 plus is approaching the negative sign of V. Okay, now what is the third question they have asked? Question number C. They have asked us to find out what I of infinity and V of infinity. At I of infinity and V of infinity, what's happening? The switch is open only, but the switch is open for a long time. At t equal to 0 minus, the switch was closed, and the switch was closed for a long time at t equal to 0 minus. At t equal to 0 plus, the switch is open for a long time and the circuit is at steady state. Everybody understand that? So that point needs to be made at t equal to 0, sorry, at t equal to infinity. Everybody, sub question C, what's happening there? At t equal to infinity. Why we are doing this? To find I of infinity and V of infinity. We are doing this. So at what time you need to do this? We need to do this at t equal to infinity. Okay, what's happening at t equal to infinity? The switch is open for a long time. Therefore, at t equal to infinity, since the switch is open for a long time, the circuit is at steady state. The circuit is at steady state. And at steady state, what's happening with L and C? L is being replaced by a short circuit and C is being replaced by an open circuit. Okay, so everybody now write the circuit at t equal to infinity when the circuit is at steady state. Just look at this. You have the circuit diagram wherein you have a voltage source. The switch is open. Find a resistor. There is an inductor and there is a capacitor. So inductor has to be short circuited. That is this short circuited inductor is this. Then this is open circuited capacitor. Fine, and the resistor values are 6 ohms and 4 ohms. The voltage applied is 12 volts. So what is this current? This current now is I of infinity, current flowing at t equal to infinity with switch open. Okay, and the voltage drop here is V of infinity. Now, can you give me what is I of infinity and V of infinity? See here, there is an open circuit because switch is open. When switch is open, there is actually no supply here. When there is no supply, this will not be flowing. Earlier in this case, here at I of 0 plus was flowing because there is no instantaneous change in the current that is flowing through the inductor. Okay, at 0 minus, whatever was the condition prevailing, the same condition would prevail at L at t equal to infinity through L. But now it is not 0 plus, it is infinity. That means the steady state has been already reached. So when the steady state is reached, this supply is not effective. Okay, when I of 0 minus was there, the same I of 0 minus was flowing at t equal to 0 plus also. But now the switch is open for a long time, the steady state is already reached, so the supply is of no use. So no current is being supplied here. So that means this current would be 0. Okay, and when this current is 0, there is no supply here, this current is 0, you will have this voltage also 0. Understand that? So this implies that I of infinity is 0 amp because there is no supply, and since no current is flowing in the circuit at all, your voltage at t equal to infinity would also be 0. Fine. So okay, this is the next problem. Fine. Here the switch is given in this position in parallel with 5 ohm. At t equal to 0, the switch is being closed. That means for t less than 0, the switch was open. Okay, and the switch was open for a long time. How can we say that? Because they are saying that the steady state is reached with switch open. That means the switch was open for a long time. Understand that? So with switch open, the circuit was at steady state. So at steady state, what happens? Okay, so we need to write that to obtain I1 of 0 minus and I2 of 0 minus. And once we get that, okay, what is I2 of 0 plus? I2 of 0 plus would be I2 of 0 minus. But do you think I1 of 0 plus would be I1 of 0 minus? No. Okay, so there we need to be little careful. Understand that? So this is little tricky. It is not as your regular problem. Fine. So let's go with it now. Okay, what's happening at t equal to 0 minus, switch is open, circuit is at steady state. Okay, so C is open circuit, L is short circuit. Get that? So the circuit looks like what? The circuit is going to look like this. How? See here, you have the voltage source, you have 5 ohms. Okay, so this is open circuit. Okay, then you have another resistor here. Okay, and this is short circuit. This is short circuit. Okay, what's flowing here? I2 of 0 minus is flowing. Okay, what's dropping here? BC of 0 minus, or you can just call it as B of 0 minus. Fine. So this is 10 ohms and 10 ohms are here. Fine. This is 5 ohms and there is the switch open. So this is how the circuit looks like. Fine. Now I'm not interested in I1 of 0 minus. They're asked to find out I1 of 0 plus. Okay, but I1 of 0 plus is not equal to I1 of 0 minus if I find out that here. Why? Because I1 of 0 minus is not the current through the inductor, but I2 of 0 minus is the current through the inductor. That's why I2 of 0 minus is I2 of 0 plus, but I1 of 0 minus is not I1 of 0. So I'm not interested in I1 of 0 minus. Let's find out I1 of 0 plus at t equal to 0 plus only. Now, with this, can we find out I2 of 0 minus? Is the question. So this is of no use. Okay, so here this path, outermost path is there. In this outermost path you will have the current I2 of 0 minus flowing. So where is this I2 of 0 minus flowing? Everybody just concentrate. See here, so this I2 of 0 minus that we are showing is flowing in this direction. This is also I2 of 0 minus. Okay, here also I2 of 0 minus is flowing. Everybody understand that point? Okay, so therefore KVL implies what? KVL implies what? Minus 20 plus 5 into I2 of 0 minus plus 10 into I2 of 0 minus is equal to 0. Okay, so what is I2 of 0 minus? Therefore I2 of 0 minus is what? 20 by 15, so it is 4 by 3 amps. Okay, since the current through the inductor, here is the inductor. Okay, since I through L does not change instantaneously. What we can say does not change instantly. We can say that I2 of 0 plus is equal to I1, sorry, I2 of 0 minus, and that's equal to 4 by 3 amps. The same is not true with I1 of 0 minus. So I'm not interested in I1 of 0 minus because I1 of 0 minus is not the current through the inductor. Okay. So we have found out the current I2 of 0 minus at t equal to 0 minus, and that is the same at t equal to 0 plus also. Now we shall find out this again. Okay. You can go with this path, the dotted path. You can form a dotted path and you can go through that. Okay, so what does that give you if you form a dotted path there? What is VC of 0 minus? See here? So we can give the polarities there. Okay, so what would that be? Go on, everybody. Catch hold of the path. Catch hold of the path where V of 0 minus is 1. There are the two paths. One is this path. One is this path. Another path is this. Go with any path, you should get the same. Okay. Let's form a dotted path here. Let's see what happens. KVL to dotted path. Gives you what? Minus 20 plus 5 into I2 of 0 minus plus 10 into 0, because through 10 ohms there is no current flowing, plus V of 0 minus equal to 0. Understand that? So what is V of 0 minus now? Therefore V of 0 minus is 20, okay, minus 5 into 4 by 3. So what would this be? Therefore V of 0 plus is equal to V of 0 minus, and that's equal to what? 40 by 3 volts. Fine. Now to find I1 of 0 plus, okay, to find I1 of 0 plus, what do we do now is this. So at t equal to 0 plus, switch is closed. Switch is closed. Is this okay with you, everybody? So how the circuit is going to look like with the switch closed? So this is it. This is how it looks like. Let's make some changes. I'll just come to it. Everybody draw that circuit at t equal to 0 plus. What's happening at t equal to 0 plus? This is short circuit. Okay. That means the switch is closed. Switch closed. Now there is this 5 ohms in parallel with the short circuit. Okay. This is I1 of 0 plus and this is I2 of 0 plus. Further, how does it look like? 5 ohms is redundant. Okay. 5 ohms is redundant. This implies that, okay, we have this 5 ohms redundant and the circuit would look like this. Okay, so this is 10 ohms, 10 ohms. What is this? 1 microfarad. What is dropping across this? V of 0 plus is dropping, and what's flowing here? It is I2 of 0 plus, and what's flowing here? I1 of 0 plus. I need I1 of 0 plus. Okay, so we can, how we can do that is this. See, you go with this path or mesh 1, you can say. Okay, applying KVL to mesh 1. Don't up, we are not marking any mesh current there. There is already a current flowing, so it's minus 20 plus 10 into I1 of 0 plus, okay, plus V of 0 plus equal to 0. So what is I1 of 0 plus? I1 of 0 plus is 20 minus V of 0 plus divided by 10. Okay, so if you substitute V of 0 plus, what is that? If you substitute V of 0 plus as 40 by 3, okay, we'll get our I1 of 0 plus equal to what? 0.67 amps. Is everybody okay with this? Now we have to find the first order differential and the second order differentials. Okay, with the same circuit we can do that. With the same circuit we can do that, but when we are doing that, okay, so we need to consider the inductance and capacitance of the circuit. Fine, so how to do it? To find di1 of 0 plus by dt and di2 of 0 plus by dt. So what are we up to? We again have to find out the current, the circuit at t say equal to 0 plus again. Okay, so we have written that circuit already in the last step. Let's write that again with a different purpose now. Fine, so this is 10 ohms 1 microfarads, 10 ohms, and 2 henries. Okay, this is I1 of 0 plus, and this is I2 of 0 plus. So can you try that now? Can you try that yourself? Apply KVL. Apply KVL. How is that possible? Now, 1 KVL implies what? Minus 20 plus 10 into I1 of 0 plus, okay, plus 1 by C integral I1 of 0 plus dt equal to 0. Okay, now what is that? We are trying to find out what the differentials, right? So differentiate this with respect to t. So what would happen if you differentiate this with respect to t? You will have the first term equal to 0, 10 into di1 of 0 plus by dt plus 1 by c into I of 0 plus, because the integral will go off when you differentiate. Okay, so this implies that di of dy1 of 0 plus by dt equal to 1 by c times I1 of rather divided by what? 10. Okay, this is what the circuit looks like. So with this, you'll find out it to be minus 0.67 into 10 power 5 amperes per second. Okay, so this is how we have found out the first order differential of the current I of 0 plus. On the similar grounds, just apply KVL to what? This path and find out the other differential. What is that? So another KVL, KVL 1. Okay, this is KVL 2. What do you get if you apply KVL to this particular path, the outermost path, to find out I of the first order differential of I2 of 0 plus? That is minus 20 plus I2 of 2 into I2 of 0 plus. What is the voltage across the inductor? It is L into di2 of 0 plus divided by dt equal to 0. Understand that? So this is how it is going to look like. Fine. So with this equation, what is di2 of 0 plus divided by dt going to be equal to, that's 20 minus 2I2 of 0 plus divided by L, and this will give you 3.33 amperes per second. Okay, this is how we can find out the first and second, first order differentials of the currents I1 of 0 plus and I2 of 0 plus. Here I1 of 0 plus and